So now let's look at the handout examples to see how we use these things. So the first handout example, which will be number 7, the directions are to multiply and simplify. So number 7 here, we have the following multiplication. We're multiplying the square root of -2 by the square root of -2. So what I'm going to do is I'm going to simplify each of these radicals so that there's no more negatives underneath contained in the radicand. So simplifying the square root of -2, well, remember how we did that. So I can write this as the square root of 2 times the square root of -1. So in the first video, I am skipping one tiny step here compared to the first video, but we're allowed to separate it this way. So that's the first square root of 2. Then I'll have the square root of 2 times the square root of -1 once again. From here, any square root of -1 that I see, I'm going to rewrite that as an I. So I'm going to have the square root of 2 times I here, times the square root of 2 times I. Now when I multiply these, we're going to multiply them just like we did in earlier sections. I'm going to multiply the two radical expressions together, and then any other numbers that are lingering around, I'll multiply those as well. So if I multiply these two, I'm not foiling or anything, right? So these aren't binomials. So I'm just multiplying the square root of 2 times the square root of 2. That gives the square root of 4. Or you might just notice that that's 2 right off the bat. That's fine. Then I'm going to multiply the I and the I. That'll give me I squared. Since we cannot have powers of I that are larger than 1, we have to use the fact that I squared is -1. So I'm going to replace this I squared with a -1 and also reduce that square root of 4. Then from here, 2 times -1 is -2. This is in A plus BI form, just because there's no i's. It's just a real number that we got back, which is fine. So that would be the answer. So let's look at the next one. We have number 8 here. Similar, a little bit more complicated. So we're multiplying the negative of the square root of -10 times the square root of -5. Okay, so I'm gonna have a negative out front, kind of towards the end, and it may or may not simplify or go away at the end. So I'm just gonna keep it there until I don't need it anymore. The first thing I'm gonna do is simplify these two radicals the same way I did the square root of 2 up there. So I'll have negative the square root of 10 times the square root of -1 times square root of 5 times the square root of -1. And I encourage you to pause this video and not just, watch the steps as they unfold. Once I do one example and you feel like I kind of understood that, maybe when I do the next examples, try to do it yourself. And if you got it right, you'll feel proud of yourself. If you get it wrong, you could at least see maybe what we did differently and how you can fix your methodology there. So continuing on for this problem, that negative still out front. I'll have the square root of 10 times I, replacing the square root of -1, times the square root of 5 times I. Again, that negative, just going to leave it out front to the end. So the square root of 10 and the square root of 5, I'm going to multiply those. And I'll have the square root of 50. There's more than one way to simplify that multiplication, but I'm just going to multiply them together. Then I'm going to have the I times the I, which once again gives me and I squared. So I'll deal with the square root of 50 at the end, but I know that I squared is -1. So now I'm multiplying a negative square root of 50 times a -1. Well, a negative times a negative is a positive, so this just becomes the square root of 50. And if you remember from earlier sections, 50, that is divisible by a perfect square. It's 25 times 2. So the square root of 50 is the square root of 25 times the square root of 2. Square root of 25 is 5, and I'm just left with that square root of 2. Again, we see that there's no imaginary component at the end, and that's because the I squared simplified to a real number, -1. Now the next four are a little bit different because we're not multiplying two radicals containing negatives, rather just expressions that involve complex or imaginary numbers. So number 9 here, we're being asked to multiply -6i times 2i. These are two purely imaginary numbers, meaning they have no real components. So when we multiply, and it's going to be true in general, when you multiply two purely imaginary numbers, you're always going to get a real number back. And that's because of this I times I situation, which will give us that -1. So let's do this. I'm going to multiply the coefficients of the i's. So that'll be a -6 times a 2. That's a -12. Multiply the I and the I, that's I squared. Remember, no powers of I larger than 1. So I can replace that I squared with a -1. And the end result, -12 times -1 will be a +12. So -6i times 2i is just +12. Let's check out number 10 here. We're going to multiply the imaginary number 7i, purely imaginary number, times the not real, not complex, but not real and not imaginary, but just a general complex number, 6 minus 5i. All of the multiplication that you know from previous classes, the foiling, the distribution, all that stuff, it's still the same. So here I'm multiplying a number times two other numbers. So I'm going to distribute that 7i into those parentheses. So I'm going to multiply the 7i times the 6. That will be a 42 times I. Then I'm going to multiply the 7i times the -5i. Okay, so the 7 times the -5, that's going to be a -35. But both terms have i's, so that means I'm going to have an I squared on that 35. From here, it's just simplification. 42 is a coefficient of I to the first power, so that's going to stay the way it is. But that I squared again, anytime you see an I squared, remember to replace that with a -1. So this becomes 42. I'm multiplying -35 times -1, so it becomes a plus 35. This is the final answer, but we want to rearrange it to be an a plus bi form. So I'm just going to put the real part first and the imaginary part second. So that would be the final answer. We have a couple more here. 11. We're multiplying 4 plus I times 9 minus 3i. Here we're multiplying two complex numbers. They also happen to be binomials. And remember, when you're multiplying binomials, you have to FOIL it, FOIL it, right? So I'm going to do first outer, inner, last here. 9 times 4 is 36. 4 times -3i is -12i. I times 9 is positive 9i. And I times -3i will be -3i squared. So in this situation, there are terms that we can combine because they're like terms. And we also have that I squared to take care of. So let's do that. We have a 36, negative 12 plus 9 is negative 3. So we'll have negative 3 i's left after combining. And we still have that minus 3 times negative 1. So this ends up being just a positive 3. So I'm going to combine that with the 36. That'll give us a 39. And I have that minus 3i left. Okay, so that would be the final answer there. We put it in a plus bi form, where the real part comes first. Do you have one more example on here? This is number 12. We're figuring out the simplified expression for 2 plus 3i squared. So remember, when you're squaring a binomial, this is a binomial, it means to multiply that expression by itself. So the first thing I'm going to do is rewrite this as 2 plus 3i times 2 plus 3i. You cannot, and I repeat, you cannot square the terms separately and think that that's the final answer. You have to multiply that binomial by itself. So this is a similar situation to what we did in number 11. We have to FOIL this. So if I FOIL this, I'll end up with 4. You can also use the binomial formula. You can use this for 2 plus 3i squared, where a is taking the role of 2 and b is taking the role of 3i. I think with complex numbers, showing those in between steps is going to be beneficial rather than just applying a formula. But you're free to use it if you like. In fact, try to use it and make sure you get the same answer. I think that's a good exercise. So here, after foiling it, this is what I end up with. Similar to the last example, I'm going to combine like terms here. I'll end up with 12i. That I squared, again, is going to become a negative 1. And that 4 is still there. So now I'm adding this 9 times negative 1, which will be a minus 9. So really that's subtracting 9. So really we have 4 plus 12i minus 9. And finally, I can combine those two real numbers to a negative 5 plus 12i. Again, I'm writing the real number in front because a plus bi form, right? So I think that covers anything that you're going to encounter as far as the homework. There may be some that are just a tiny bit tougher than others. So again, try them out and come to class with questions. That's the whole point of our discussions. So I'll end this video here, and I will cover the next two sections, D and E, in the next video.